Okay, so if we there we go. Okay. So if we talk about, real quick, I want to pay attention to the language here. I think it's really important for us to pay very close attention to the language. And if we have something like this, where it says we want to evaluate a function or evaluate an expression, what does that word evaluate mean? As distinct from and different from if we're asked to solve something or simplify something. I think sometimes with math students, probably not as much with this group, but I think sometimes when these words get thrown at us, they all kind of run together. They all sort of come to mean the same thing, but they don't. They're very different things. What does that mean when we talk about the word evaluate? You're supposed to evaluate the expression 7 plus 4 times 3. What does that mean? If you're evaluating something, I've got a close friend whose dad is an NFL scout. So he scouts college football players. And when he's done, he watches them play, looks at film, and then he writes down a rating for them. It's a number, right? So when you're evaluating something, what are you doing? You're trying to attack. Go ahead.
Solve it.
Okay, solve is the word, and that's 9 times out of 10. That's the word that gets thrown out. I know what you're saying, but it's really not what I'm looking for. Solve is something different.
Like study it, kind of.
Study it, good.
Size it up.
Size it up, good. I like that. So far, that's the one I think gets closest to the answer. Evaluating means, yeah, we want to attach some kind of a value to it. Evaluate means attach a value. In math, what does value mean? If I just pull out 2 bills and I say, okay, you can have one of these, how are you going to choose which one you want? Pull out of my wallet 2 bills. What do you mean by the bigger one? There's more money, the one that has a higher value, right? So when we pull out a bill, the value of the bill has to do with the size of the number on the bill, right? Okay. Same thing in math. Value means number, right? So we want to turn this into a single number. We've got this mishmash of different numbers that are connected with operations. And math operations are what? Things like multiply, divide, add, subtract, right? And we want to turn that into a single number. Well, we have to have some organized system of rules to do that, though, to evaluate something. Okay? So, continuing on. Why is it doing this? I'm having some issues today. My goodness. Okay, so we know that it's 19 because order of operations, right? You know order of operations. PEMDAS, please excuse my dear Aunt Sally. Okay? You have to be careful with that, though. Order of operations is hugely important. I would say 95% of sort of elementary algebra, Algebra 1, and even most of Algebra 2, is taken care of by knowing how to use order of operations correctly. It's one of the single most potent, valuable things that we have in math. If you can use that well, you get a lot of mileage out of it. But you got to be careful. What does this PEMDAS say? What are these? It's an acronym. What do all the letters stand for? What's P? Parentheses. How come that's the first one? How come that comes first in PEMDAS? Or please excuse my dear Aunt Sally. What do you think?
Because it means you have to focus on that little section first.
Okay, so that's the first thing to take care of. Parentheses, right? So in the order of operations, that's number 1. What's number 2? Ah, I heard it. Exponents, yeah. Or powers, whatever you want to call them. Exponents fits nicely in PEMDAS, though, so we'll call them exponents. That's next, after parentheses. What's next? Okay, what's after that? Oh, there's the problem. See, that's really not right. What's wrong with that? Say it again. They go, okay, they fit together, don't they? Same thing with addition and subtraction. So here's how I'm going to insist. Here's how I want you to write down order of operations. This is the best way to do it. Write them down as a tree. So you write them vertically. Like that. That makes more sense, doesn't it? Because that tells us that, yeah, parentheses comes first, sure. Then exponents. By the way, we're always talking from left to right, aren't we? Like we're reading a book, across the expression from left to right. Then, this is telling us that multiplication and division are equal. They're on the same level. So we're going to take care of multiplication or division, whichever comes first, from left to right. And then addition or subtraction, they're equal from left to right. And so that's, if you write it that way, you don't confuse that. This sounds a little dorky, but this will help you remember it. If you're going to say the whole "please excuse my dear Aunt Sally" thing, here's how you got to say it. You got to say, "Please excuse my dear Aunt Sally," because the M and the D go together, and the A and the S have to go together. So if you kind of say it with that cadence, then that'll reinforce that. But this is the best way. Just write that tree down. Okay? Yes.
Where do roots fit in?
Good question. Anybody know where to? What do you think? Exponents. Yeah, they do. Good. And we're going to talk about that today. It's a good question. So what if we have? There's a reason for that. I don't know if you guys would have talked about this or not, but did you in last year? Did you talk about something like this? If we have, say, the square root of x, that's equivalent to saying x to the 1/2. Remember talking about that just a little bit? It's not really critically important at this point for, if you haven't had a real need to think of it that way. This year we will. I mean, we'll do some of that stuff. But what's important about that is anytime you have a radical, you can always write it as an exponent. Okay? So for that reason, they fit in right here. Okay? Any kind of root. What if it were a cube root? Cube root of x. Any ideas what power that would be? 1/3. Yep. And we'll talk more about this, as we progress through math, we'll talk more about this. But whatever the index of the radical is, that little number that sits on the radical, and there's an invisible too there, isn't there, in a square root? Whatever the index of the radical is, that's the denominator of the fractional power. Okay? Okay, so good question. That's where roots fit in. And more along that line, a lot of this stuff that we'll do, even next year in Honors Algebra 2, a lot of those things that aren't immediately obvious that they fit in here somewhere, they do. We can always make them fit into this order of operations tree. Okay. So, moving on. Parentheses. Now, the thing about parentheses is, parentheses don't have to just be parentheses, right? Parentheses could be brackets. They could even be other kinds of grouping symbols. So by parentheses, we mean grouping symbols. What's another example?
Absolute value.
Absolute value bars group things together, right? Sometimes even functions, as we'll see, can group stuff together, right? And we'll look at an example like that later today. So parentheses, exponents or powers, multiply and divide left to right, add and subtract left to right. So really quick, crank that one out. Okay. What'd you get? Luke, what'd you get? 1 is correct. Good. How did we get that? First thing you take care of? Okay, good. We got left to right. There's no parentheses, agreed. No exponents, so we start with multiplication and division. 14 divided by 7 is the first one we encounter from left to right. That's 2. Now what? 2 times 2. Good. 4 minus 3. 1. Good. Piece of cake, right? Okay, try that one. Brooke, what'd you get? Didn't get, okay. Everybody done? What do you got?
60.
60's correct. What'd you do first?
I did 7 plus 3.
Okay, good. We have parentheses here, don't we? So when we have parentheses, we have to deal with everything in the parentheses first. This was pretty easy, 3 plus 7. But what if, hypothetically, what if there had been a whole jumble of stuff inside the parentheses? How would we decide what to do first inside the parentheses? PEMDAS, same thing, right? We'd go back and use our list, our order of operations tree to work inside the parentheses to make them one thing, right? Simplify. So first step, 3 plus 7 is 10. What's next? Square it. 10 squared is, okay, and it's not 3 times 10 squared. It's 3 times 10 squared, right? See the difference? The 10 is what's being squared. 10 squared is 100. Now what? 3 times 100, we got to go left to right, is 300 divided by 5 is 60. Very good. Okay, one more real quick. Think that out. Okay. You get an answer, Alex?
Yeah.
What'd you get?
126.
126. Okay, well, we'll see. We'll check it. See. What's the first thing we got to do there? What do we do?
Parentheses.
Parentheses. 6 plus 1. 7. Okay, what's next? Exponents. 10 squared, 100. Okay, now what? Okay, so which one technically do we do first? 3 times 6, 18, and then now it's easy. Right now it's just, now we got it down to just a string of terms that are being added and subtracted, so we just take care of it. 20 minus 18? 2. Oh, I think you got negative 2 there, didn't you? That's what it was. 2 plus 100, 102, that's what it is, yeah. Plus 28, 130. I see how you got it. You just got negative 2.
Yeah.
Okay, make sense? Okay, these are getting too easy. I'm gonna throw a doozy at you. Let's try. Okay, how about this? What if we've got yikes. Ugly, huh? Okay, but first rule in math is don't get intimidated by the numbers or the size of the problem. Right? Inch by inch to cinch, yard by yard, pretty hard. You just gotta take it one step at a time and follow the rules. But this looks a little different. So before we jump into this as a group, let's see if we can get our thinking straight on this real quick. Okay, hold that thought, we'll come right back to it. I want you to tell me something now. What number is this? We'll go right back to it, I promise. What is that? 2/3? Clear enough, right? Okay. What's this? What is it? 1/2? Or what else could it be? 2/3 plus 1, so what? 5/3? Which one is it? That's a really dumb way to write that, isn't it? Isn't it? It's not clear. How should I write that instead? Ah, okay, good. We never, never, never write fractions as slashes. We always write fraction bars, so we can avoid that mistake. So now we know, is it this? What's the answer to that? 1/2. Or maybe it's not, maybe it's this. Either way, we know now, don't we? It's very clear. Okay? So we always write with fraction bars. Okay, so what about this guy? Now let's just talk about this. What's the first thing we're going to do here? Okay, yeah, parentheses. Now where are there parentheses? Sometimes there are parentheses that are implied. They're not written directly, but they're there. Okay, so say it again. Inside the square root, because we're taking the square root of all that stuff, aren't we? Now technically, and this is pretty advanced, we'll get to this, more next year, but another way of writing that radical would have been writing it this way. We could have said 2 plus 2 times 3 plus 8, that quantity to what power? To 1/2, right? We don't have to know that now. I think it's helpful to see it that way, but either way you slice it, we have to put some parentheses around everything that's inside the radical, don't we? Okay, those are called, once again, implied parentheses. What does implied mean?
It's like there, but not there.
Okay, yeah, sort of indirectly stated, right? Didn't come out and say it explicitly, but we know they have to be there, right? So there are some implied parentheses. Any others? What do you think? Ah, okay, the entire bottom. Good, very good. Okay, and probably if I had sicked this problem on you guys, you by and large would have gotten it correct. Your intuition would have guided you. But it's important to recognize that every time we have a big fraction like that, there are implied parentheses around the whole numerator and the whole denominator, right? Does that make sense? So there's really one more pair there that we need. Where would those go? The top, yeah. Okay. Now that helps us out. Now that really organizes it for us. When we have parentheses within parentheses like that, which we might call nested parentheses, where do you start? Good. You start on the inside and work your way out, don't you? Okay. Does that all make sense? Okay, so this is a hard one. If we can do this one, we can tackle anything. This is a big time problem here. So, what's our strategy then? Doesn't really matter if we start on the top or the bottom. We'll just take care of the top and then take care of the bottom by itself and then ultimately just divide, right? So how about if we tackle the top first? On the top, what's the first thing we do? Okay, we got to do everything inside the blue parentheses, don't we? And there's an order to that. If we just focus only inside the blue parentheses, first thing we do, 2 times 3 is, that becomes a 6. So then we get 2 plus 6 plus 8. 16, right? So we get, on the top, 2 times the square root of 16 plus 8. Oops, no, never mind. Square root of 16 plus 13, right? Everybody agree? Mm-hmm. These are brackets. That's another thing. Why? I could have made parentheses there, but minor point, but I think all this stuff kind of helps. Why brackets? Oh, because I already have parentheses, so it makes it easier to keep track, right? If I had 3 layers there, what might the third layer look like? You could go parentheses again if you, anything would work, but tell you what, any other suggestions? Yeah, here's what I would do. Larger brackets, or I would do probably script brackets for the third layer. So that kind of helps a little bit, then you can kind of keep track of what goes where. Okay, so there's the top, first step on the top. What about the bottom? What do we do first on the bottom? 3 minus 1 is 2, so we're going to get 2 squared plus 1. And we really don't even need those parentheses, do we? I mean, they're implied. In fact, it almost kind of confuses the issue. If you want to write them, great, but we know, whoops, there we go. We know they're there because we've written this using fraction bars like we should, so maybe we just leave it like that. Next step on top. Square root of 16 is 4. So 2 times 4 plus 13. Oh, I thought I planned this a little better. Guess I didn't. Whoops. On the bottom. Okay. And then finally on the top, 2 times 4 is 8 plus 13. Bottom. Okay, can I, go away. There we go. Can I simplify that fraction at all? Nope. That's my answer, isn't it? 21 fifths. Okay. Make sense? Got it? Okay, what happens if we add another wrinkle? This isn't much, but tell me how we deal with, skip forward a little bit here. Oops. Let's go back one. That looks scary. Look at all those variables. So what this problem is asking us to do is evaluate for the variables. What's that mean? Value means number. Evaluate means numberify, essentially, right? We're going to numberify the variables. We're going to plug in the numbers for the variables and then do what we've been doing, right? Simplify. So the only additional step here is every place I have an X, I'm plugging in a 5. Every place I have a Y, I'm plugging in a 2. Every place I have an N, I'm plugging in a 3. And now same stuff we've been doing. Make sense? No biggie, right? Okay, let's review questions so far. Is that all making sense? Coming back? Okay, let's review adding and subtracting fractions real quick. I know this is going to be old hat for you, but let's just humor me. Let's just take a second. And what if we have, let's say something like this. What if we have what do we do? Okay, common denominator, right? And we have a couple ways of doing this. Like I said, there's a right or a wrong way. We could combine two fractions and then combine the third. You know, see what I'm saying? We could just forget about this guy for a second, add up or subtract those first two fractions, get an answer, and then add that 5/6 to that answer separately. Or we could sort of tackle these all at once with one big common denominator, right? Either way, let's do the second one, just, next time we'll do it differently. So what is the least common denominator of all three of those numbers? 12. Okay, good, 12. So to get 12, what am I multiplying the first one by? 3 over 3. So what do I get? The first one becomes 3 twelfths. Second one becomes 8, so minus 8 twelfths plus 10. That makes sense what I did? Okay. So what's our answer? 15. Okay, so we get -5. That's right, -5 plus 10 is 5. Does that simplify? Nope. That's our answer. 5/12, right? Okay. Is this harder or easier? I say easier. I say multiplying and dividing fractions is much easier than adding and subtracting. How come?
You don't find a common denominator.
Just no common denominator, just multiply straight across. But what do we do with this? You divide by a fraction, the same as multiplying by the reciprocal. Good. So the only little switcheroo we have to do here is this. We're just going to rewrite this as 1/4 times 2/3 times 6/5. And we can just multiply straight across, or when we're not adding and subtracting, but when we're multiplying fractions, we can take advantage of what? Cross cancellation, right? So what's some good cross cancellation that might be helpful to us?
3, 6, and 2.
Okay, 3 and 6. Okay, 3 goes into 3 once, it goes into 6 twice, and 2 fourths. 2 goes into 2 once, into 4 twice. Now we can multiply straight across and we get 1 times 1 times 2. It's 2 over 2 times 1 times 5 tenths. So I guess we could, oh look, we could have canceled the 2's, couldn't we? Even, yeah. Either way, we can just reduce this now. What do we get? 1/5, right? Good. Okay, so for you guys, I'm gonna go a little further today. And then the assignment, I actually don't have your assignment up, but I'll have it up right after school. So if you go to Moodle, everybody know how to get to Moodle? When we're all done, when are we done? 1:20. Okay, so stop me with like 5 or 6 minutes to go. And then I'll pull up the assignment so you can see it and you'll know where to go and what it would look like. I'll go to the regular geometry class. It'll look pretty much the same. Okay, so we know that for order of operations, this is where I'm going to kind of leave off for today. This is the direction that we go, normal top to bottom, whenever we're trying to evaluate or simplify, okay? That's order of operations direction for those things. What if we want to do something like this though? What if we want to, say I want to solve the equation how can I use order of operations there? Any ideas? What do you think? Bottom up. Okay, good. If we're going to either isolate a variable, which is really the same thing as solving for a variable, we reverse the order of operations and go top up, right, to get the x by itself. So what's the first thing we would do then? Good, we're going to undo addition and subtraction by subtracting or adding, right? So first thing is we'd add 3 to both sides, that's that step. And we get 2x equals 10, and then, good, we undo multiplication by dividing. And that's easy, I know you guys knew how to do that. But the point I wanted to make there is I want to make it very clear how that single order of operations tree really takes care of both of those, both directions. Okay, let's throw a couple more at you here. How about something like this? What if we have that? So let's write the order of operations tree up here because that's going to guide. That's going to guide our thinking. What are we trying to do here? I didn't write the instructions down, but what clearly are we probably trying to do in that problem? Solve for x. Same thing as isolating x, right? What's the first step? Okay, good. So we're going to go. Now, look at this. When do we get to parentheses when we're working backwards through order of operations? Last, right? So now, outside of parentheses, we want to find, first we're trying to undo any addition and subtraction outside of parentheses. So that's right there, isn't it? Right? So first step is subtract 1. Okay, what's that give us on the left? Well, it just gets rid of that term, right? Notice the use of the word term. What does a term mean? Say it again.
A number and its value being positive or negative.
Okay, well, yeah, it could be a number, but it doesn't have to be. A term is just something that's being added or subtracted in an expression, okay? Terms are added or subtracted. So because that one was attached to the other stuff by addition, it's a term. We get rid of that term by subtracting. Does that make sense? Just want to get you used to the terminology. So then we get 3/4 times, how would we say that? 3/4 times, what do we call that thing? Yeah, you're right. But how do I say that whole thing combined? 3/4 times the, starts with a Q. Quantity. Yeah, that's how I'd say this in math. I'd say 3/4 times the quantity, 2x cubed minus 4. Does that make sense? Okay, that's how I should say that. Equals, what do I get over here? Okay, what's next? Ah, okay. Yeah, the 3/4. How do I undo multiplying by 3/4? Okay, I'm dividing by 3/4, but really we never divide fractions. We always multiply by the reciprocal instead, right? So we multiply both sides through by 4/3 and cancels that fraction, right? And so I get 2x cubed minus 4. Do I need the parentheses anymore? No, because I peeled it back to the parentheses, and so now I can get rid of them, right? Does that make sense? Equals, what do I get here? 12. Okay, so now that we're inside the parentheses, we start all over again. Start at the bottom, work our way up, so we have to undo subtracting 4, add 4. What's that give us over here? Well, 2x cubed on this side? 16. Okay, now what? Okay, good. We did addition. Now we got multiplication comes next. Multiplication and division. We got to undo the multiplication by dividing. Gone, right? X cubed equals 8. Okay, now this is a little strange. This is something that you wouldn't have done a lot of. But how do you undo something like that? Not square root. Cube root. Yeah. So what is the cube root of 8? 2. Good. Is it a plus or minus 2?
Plus.
Plus. Just plus, isn't it? That gets a little complicated. Do you remember last year when you square root both sides, you got to put a plus or minus in? Okay, we'll talk more about that later. That's our answer. How do we know if it's right? Plug it back in. Yeah. Whenever. This is great. Whenever you are doing a problem that says solve, it's so easy to check because you're going to get the value of the variable. Just plug it into the original equation and see if it works. You know if you got it right or not. All we got to do is go back up here. If I plug in 2, does it work? Well, let's see. What's 2 cubed? 8 times 2 is 16. Minus 4 is times 3/4. 9 plus 1 is 10. Yeah, check. It works. How about that? Good stuff? Okay. All right, so we're getting close to the bitter end. Let me pull up an example of what an assignment looks like. Okay, so if you, whoops, let me do something real quick here. Okay, so if I become a student, this is what the regular geometry class looks like. It's just about what the honors geometry class Moodle will look like. When you go in there, you're going to see for each section that we cover, there's going to be a section of resources. And so if you click on this, you'll see the PowerPoints, for example. We didn't go through the solving for single variable PowerPoint. I don't even know that we will. We might take a brief look at it tomorrow, but I kind of doubt it. I don't think you'll need to. We looked at the order of operations PowerPoint. All those resources are there. Okay, what happens if you don't have Microsoft Office, so you have PowerPoint? Do you have to have that to view these things? No, you don't. There's a couple of good options. One good option is something called, in fact, I'll go right to it here. This. Open Office. Okay, Open Office is a free piece of software. It's like a clone of Microsoft Office, but it costs $0. It's got the same kinds of stuff as Microsoft Office does. They call them different things. I can't remember what they're called, but it's got some program that's just like Microsoft Word, some program that's just like Excel, and something that's just like PowerPoint. So you can download that on your home computer and have a fully functional, Office suite of really powerful programs to use for free. Highly recommended. I would not spend the money on Microsoft Office if you don't really want it. This is a good one instead. The other thing you can do, so that's option A. Another really good option is hang on. How's it doing this? There we go. Okay, right here. This. PowerPoint Viewer is a free Microsoft. Oh, can't see that. There you go. PowerPoint Viewer. I'll put links to these on the website. PowerPoint Viewer is a free piece of software that allows you to download and open up and view slideshows. You just can't create them. But you don't, for this class, you don't need to. All you need to do is probably just look at the slideshows that I put up there, right? Both of those freely available, good additions to your home computer. I don't know what would be available exactly for like a smartphone or a tablet, but same kind of stuff. I know you can get free software for opening up and viewing PowerPoints. It probably even comes on most smartphones. Anybody know what would it be called? Like on a what would you open up on an iPhone to look at a PowerPoint? Does anybody know? I don't. But I know you can open up PowerPoints and look at them on an iPhone. You might have to download an app, but it's easy to do. Okay, questions? Okay, so going back to the site, this is what you'll see if I go back to home in geometry. Whoops, not what I want to do. Home in geometry, I can see there's the resources. Here are the practices. So if I go to the practices, these are the little online practices that you do. So there's only one of them up there for geometry. I'll probably put 2 of them up for you guys. I'll put up an order of operations practice. If we open this up, here's what you see. Attempt quiz. Yeah, let's go ahead and do that. Attempt quiz. Take a second to load. And then you better get out of here. But then this is what you see. You see a bunch of problems that you'll answer step by step. Make sense?
Do you want us to do both of them?
They're not due tomorrow, but you might want to get a help on them.